so now we're actually at the solve for x kind of problems for solving inequalities. So solve and graph on a number line. So let's take a look at problem number 1. I just want to reassure you guys' anxiety. Let's pretend that this is an equal sign. If this was x minus 5 equals 3, what would I need to do? Yeah, I would add 5 on both sides. So remember, the only thing that's different is we have this little table. Today's going to be an easy day. It's just going to be addition and subtraction. So let's take a look at this. So if we have x minus 5 is greater than 3, remember that symbol means greater than 3, then we treat this like an equals problem, but we look at our table. If we need to add 5 on both sides, that means that the inequality is still true, so the sign will stay the same. And so if we add 5 to both sides, negative 5 cancels out with positive 5, and I get x isolated. The sign stays the same because addition on the left and right has no impact on the true statement. So x is greater than 8 legally. So that's our solution. In order for x minus 5 to be greater than 3, x must be a number greater than 8. So I make a little number line to myself, just a horizontal line with 0 in the middle. Where is positive 8 compared to 0? On the left or on the right? It's on the right. All I care about is that it's on the right. It doesn't have to be like exactly drawn on the scale. So I put a little endpoint on the 8, so I'm going to circle that. Okay, and where do I shade? All numbers greater than 8. What are all the numbers greater than 8? To the left or to the right of 8? To the right. So I've reached the end of the number line, so I put a big fat arrow. Okay, and just if you want to check your work, give me a number that's barely bigger than 8. Let's go with 9. 9 minus 5 is 4. 4 is greater than 3. That is a true statement. Let's go with one number to the left of 8. Let's go with 7. 7 minus 5 is 2. 2 is greater than 3. That's not true. So anything that is in the shaded region is a true statement. Oh, I almost forgot to ask. X is greater than 8. Is 8 itself included in the solution set? No. It says greater than, not greater than or equal to. Because if I plug in 8, x equals 8. 8 minus 5 is 3. Is 3 greater than 3? No, it's equal to 3, so therefore it's not true. So anything in the red shaded region is true. Let me just make sure it doesn't bleed through the paper. No, it doesn't. Good paper. Good paper. Good doggy. So let's take a look at this problem. X plus 4 is less than 10. So if this was an equals sign problem, what would I need to do? X plus 4 equals 10. Well, I would subtract 4 from both sides. So now that cancels out. I'm going to look at my little table. What did I do on both sides? I subtracted 4 from both sides. So that keeps the inequality true. Therefore, the sign needs to stay the same. So now that I've gotten x isolated, I've got x is less than 10 minus 4. 10 minus 4 is 6. So the final solution is x, you can be any number as long as you are less than 6. So I make my little number line, horizontal line between negative infinity and positive infinity, zeros in the middle. Where is 6? Doesn't have to be drawn to scale, as long as it's to the right. So I draw 6 to the right of 0. I circle it. Okay. Where are the numbers less than 6? To the left or to the right? To the left. So I shade, make it obvious. And I'm shading to the left of the endpoint 6. I've reached the end of the number line, so I put a big fat arrow. to go to negative infinity and beyond. But is 6 itself invited to the birthday party? Can x actually be equal to 6? No, it's saying all numbers less than 6 are legal. Let's plug it in. Let's go with 5. 5 plus 4, less than 10. 5 plus 4 is 9. And 9 is less than 10. That's true. But if I go with 6 itself, 6 plus 4 is less than 10. 6 plus 4 is 10 itself. Is 10 less than 10? Nah. Let's go with 7. 7 plus 4. 7 plus x equals 7 plus 4 is 11. 11 is less than 10. That is not true. Everything that's shaded is legal. Everything that's not shaded is illegal. The goal is to figure out what values of x make this statement true. Okay. X minus 2 is less than or equal to 3. So what do I need to do? If this was an equal sign problem, I would say x minus 2 equals 3, so I'm going to add 2 on both sides. Negative 2 plus 2 cancels out. Because I added 2 on both sides, that keeps the inequality statement the same. So I'm good. The sign stays the same. So now I've got x is still less than or equal to, let me make that clear. Okay, x is less than or equal to 3 plus 2, which is 5. So now I go to the number line, and positive 5 is to the right of 0. So I circle the positive 5 endpoint, and this is x is allowed to be all numbers less than or equal to 5. So all numbers less than 5, sorry, I just moved the paper a little bit, go to the left. And I'm at the end of the number line, so I put a big fat arrow. All right. And now, x is less than or equal to 5. Is 5 actually included in the solution set? Yes. So I'm going to color it in. So if x can, in fact, equal 5, we fill in, and anything that is shaded is a true statement. Okay, so let's plug it in. Let's go with a number barely less than 5. Let's go with 4. 4 minus 2 is 2. 2 is less than or equal to 3. That's true. Let's go with 5. 5 minus 2. 5 minus 2 is 3 itself. 3 is less than or equal to 3. Yes, hence I shaded it in. Let's go with 6. 6 minus 2 is 4. 4 is less than or equal to 3. 4 is not less than 3. It's not equal to 3, so that would be a false statement. So that's why it's not shaded. Okay. X plus 8 is greater than or equal to 20. Okay, well, let's solve this problem. So if x plus 8 was equal to 20, I would need to solve for x by subtracting on both sides. Let's subtract 8 from both sides. Okay, so then x, because we subtracted from both sides of the inequality, that means that the sign stays the same. So that means x is still greater than or equal to 20 minus 8 is positive 12. So that is our solution set. So the solution is x can be any real number as long as it is greater than or equal to 12. So I put the endpoint to the right of 0. I'm going to circle it. Right? And where are the numbers greater than 12? To the right of 12. So then I put a big fat arrow. And is 12 itself invited to the birthday party? Yeah, x can be greater than or equal to 12, so the endpoint itself gets filled in. So that's how you know. Let's try 13. 13 plus 8 is 21. 21 is greater than or equal to 20. 12 plus 8 is equal to 20. So 20 is greater than or equal to 20. Therefore, 12 is totally valid. 11 plus 8 is 19. 19 is not greater than 20. It's not equal to 20. Therefore, it's not part of the solution set. Okay. Sorry about that. My marker almost fell down. All right. X plus 9 is less than 7. If this was an equal sign problem, I could solve this x plus 9 equals 7 by subtracting 9 from both sides. So if I subtract 9 from both sides, once again, what did I do on both sides? I subtracted from both sides, so the inequality still stays the same. So plus 9 minus 9 cancels out, leaving me with x is still less than 7 minus 9 is negative 2. So, once again, x can be all numbers less than negative 2. How do I graph that solution? So I make a number line, and the endpoint is negative 2. Negative 2 is on the left of 0. So I'm going to circle the endpoint. And what numbers are less than negative 2? To the left of negative 2 or to the right of negative 2? To the left. So I shade to the end of the number line, and I'm going to put a big fat arrow to say it's going to negative infinity and beyond. Okay? Number 6. X minus 13 is greater than or equal to negative 2. If this was an equal sign problem, if this was an equation instead of an inequality, x minus 13 equals negative 2, I would get x isolated by adding 13 to both sides. So, because I added on both sides of the inequality, the sign has to stay the same. So that would mean x is greater than or equal to negative 2 plus 13. That would be positive 11. So I've got x is greater than or equal to positive 11. Therefore, I've got 0 in the middle. Where is positive 11? Positive 11 is to the right of 0. So that's my endpoint that I care about. Sorry, I gotta hold the paper in place. So I'm gonna circle it. What numbers are bigger than 11? To the left or to the right of 11? To the right. X is greater than or equal to 11. Now, it's greater than or equal to 11. So is 11 invited to my birthday party? Yeah, x is allowed to be 11 itself because it's greater than or equal to, so I'm going to shade it in. So therefore, this is what the graph looks like. Okay. All right, x minus 17 is less than negative 21. See if you can do this problem independently. And when you're done with that, see if you can do this problem independently. X plus 12 is greater than negative 4. So these are the two problems. X minus 17 is less than negative 21. X plus 12 is greater than negative 4. Okay. So now that you've paused it and tried it independently, let's solve this. So we've got x minus 17 is less than negative 21. So if this was an equal sign problem, I would add 17 on both sides. The negative 17 and the plus 17 cancel each other out, leaving me with x is, because I added on both sides, the inequality symbol stays the same. Negative 21 plus 17 is negative 4. So the solution is x can be any real number as long as it's less than negative 4. I get my 0 in the middle. Negative 4 is located to the left or to the right of 0? To to the left. And it's all numbers to the, x is less than -4. The numbers less than -4 are on the left side of -4. So I'm going to shade to the left and put a big fat arrow. Is -4 itself invited to my birthday party? No. So x is less than -4, has an open circle at x equals -4. It's not allowed. All right? Same thing over here. If this was x plus 12 equals -4, I would subtract 12 from both sides. And now positive 12 and minus 12 cancel each other out. And now I've got x isolated. Because I subtracted from both sides, the inequality symbol stays the same, greater than. -4 minus 12 becomes -16. So as long as x is greater than -16, this statement is true. Where is -17? To the left or to the right of 0? To the left. So I'm going to circle that endpoint. X is allowed to be any real number as long as it's greater than -16. So it's all numbers to the right of -16. And at the end of the number line, I put a big fat arrow. Is -16 itself invited to the birthday party? No, it says x is greater than -17, not greater than or equal to, so we leave that endpoint open because it's not allowed to be part of the solution set. Now, just to make sure that we're clear on this, x is on the right part of the inequality instead of the left part, but we're not afraid of that. Again, the key is to look at the inequality and pretend that it's an equals to problem, but remember, what are we allowed to do? We're allowed to look at this table and see, does the inequality symbol flip or stay the same? And remember the grammar lesson I taught you. Depending on what starts the sentence, you can always flip it around and use a different description. So if I take a look at this, I've got 4 is less than or equal to x plus 7. So what I can do is treat this like an equation. I'm going to get x isolated by subtracting 7 from both sides. Positive 7 and minus 7 cancel each other out, and 4 minus 7 is -3. Now, I keep the inequality symbol the same and say -3 is less than or equal to x. So even though this statement is technically true, it's difficult to graph, at least for me. It's difficult for me to graph if x is on the right side of the inequality. So remember, if -3 is less than or equal to x, that means that the inequality symbol says x is bigger than or equal to. So I'm going to start the sentence with x. So I've moved the right part to the left, and I say x is, since it's getting favored, I'm going to say it's greater than or equal to -3, because that's easier for me to understand. So now that I've got -3 as my endpoint, I'm going to circle it. And if x is greater than -3, I'm going to shade to the right. And at the end of the number line, I'm going to put a big fat arrow. And now it's greater than or equal to, so is -3 itself invited to the birthday party? Yes. So anything that's bigger than -3 and including -3 is legal to plug in for x. But like I said, there's many ways to approach it. So if you're able to solve for x on the right side, and then switch it at the end, go for it. But another way you could do this is literally start the problem by switching both sides. If 9 is greater than or equal to x minus 11, why not start the problem with x, oh, sorry, I don't want blue, I want black. If I start the problem with x minus 11 on the left side, where is the arrow favoring? As in, which side is bigger? The 9. The 9 is greater than or equal to x minus 11. So I'm going to point the arrow to the other side. So another way to do this is to rewrite the problem as x minus 11 is less than or equal to 9. So now I'm going to treat this like an equation. X minus 11 is less than or equal to 9, so I'm going to add 11 to both sides. So now I've got x isolated. I added on both sides, so that has no impact on the inequality statement. So that still says x is less than or equal to 9 plus 11 is positive 20. So x can be any real number as long as it is less than or equal to 20. So that's my endpoint. I'm going to circle the endpoint. And what numbers are less than or equal to 20? To the left or to the right? All numbers less than 20 are to the left. And I shade, I make it obvious. I reach the end of the number line, so I'm going to put a big fat arrow to go to negative infinity and beyond. And positive 20, is positive 20 itself invited to the birthday party? Yes, x is allowed to be any number less than or equal to 20. In other words, it could be at most 20. That means that 20, the endpoint itself, is included. So that gets colored in. Okay, so in the next video, we'll be doing problems with multiplication. Be careful, because in order to undo multiplication, we need to divide. Be careful whether we divide both sides by a positive or both sides by a negative. That'll be in the next video. Have a good day.